So this is lesson 84B, and we're continuing on with functions. We're just going to do a few examples here. Shouldn't be too hard. And what they're doing is they're saying, does the diagram, and I'm looking at example 84.5, and they give me three numbers to put in the function machine. It doesn't matter what they do in that machine, whether they add 6 to it or, whatever. All I care about is the picture and the numbers that they're pointing toward. And the question is that a function? Alright, so what do we have here? We have one arrow coming from each number. If we only have one arrow coming from each number, then it's a function. We don't care about anything else. If, for example, I had an arrow here, do that. Now I've got two arrows pointing from the one number on the left, which is the domain, to two numbers on the right. Therefore, it would not be a function. But if I only have one arrow pointing from my x to my y, from my left to my right, from my domain to my range, then it's a function. So that one is a function. Alright, let's look at the next example. And it gives me a y, an a, and an m. We don't care what they are, whether they're letters or numbers or whatever. We just care about the arrows. Alright, so I've got that. So my y points to a p, my a points to an x, my m also points to my x, and my m points to my s. Alright, is that a function? Well, the question is there only one arrow pointing from each of these letters to one of these letters? Y to p, yes. A to x, yes. M to s, no. It's pointing to two different letters, so that way this whole thing is not a function. If one of them is different, if one of them points to 2 on the other side, then the entire thing is considered not a function. So what if I have an A, a 4, and a 7? Again, we don't care if they're numbers or letters, we just care about the arrows. And we have here, we have here, and we have here. Alright, the question is, do we only have one arrow from each of these letters or numbers? One arrow, one arrow, one arrow. So it is a function. It doesn't matter that these two point to the same number. We just care if there's one arrow. Alright. And let's look at one more here. And we have all the numbers in the whole wide world. We'll call those real numbers. That's our domain. So those are the numbers that we're going to use here. And my function machine, the numbers that I'm going to put in here is going to be y equals x plus 2. So when I put numbers in here for x, what kind of y am I going to get? So if I put a 3 in there for an x, so if I put a 3 in there, it's going to give me a 5 for the y, or my range, right? 3 plus 2 is 5. So the question they're asking for this is, if I use any number in the world for a domain, will each of those numbers only give me one answer? So if I put a 3 in there, and I get a 5, 5 plus 2 equals 5. If I get a 5, will I ever get anything but a 5 when I put a 3 in? No. So I only get one y value, or one answer, for every number that I put in here. Therefore, it is a function. Okay, so that's it for lesson number... no, I guess they do give us a couple more examples here, so let's just kind of continue on with those. Hopefully you're finding this not too hard to do, maybe not understanding exactly what's happening, but that's okay. Alright, so we've got example 84.9. I've got 4, 6, 7, 2, 4, 5. Alright, they're asking, is this a function? Well, all we have to do is look at our first numbers. If they repeat each other, then it is not a function. Alright, let's look at the second one. We have 4, 8, we have 15, 6, and we have 11, 7. Okay, all we care about is this first number. Do they repeat? No, they don't. So yes, it is a function. Okay? And let's see, if you look at example 84.10, I'm not going to do every one of these, but if you look at A, You'll see that it is a function because the x values do not repeat themselves. You look at b, and notice the x values do repeat themselves. The first set, which is 1, 2, and the third set, which is 1, 3. The 1's repeat themselves, so it is not a function. C is also not a function because my 4's repeat themselves. Now, if you read your book under the solution, it says that C is a function. The book is wrong. I love proving the book is wrong. Anyway, D. D is also a function because we have a 1 for x, a 4 for x, a -1 for x, and a 3. So even though we have a 1 and a -1 and the number's the same, because the signs are different, it means it's a different number. So the numbers really are not the same. They just both share the numeral 1 with their positive and negative. All right, if you look at example 84.11, does the diagram designate a function? All right, let's draw it there. So we've got 7, 6, and it spits out an 11, a 4, and an 8. And it maps to that. This maps to that and maps to that. 2 lines coming from the same number. Not a function. All right, one more here and then we will be done. This one looks a little tricky, but it's not. 6, 7, 8. I'll leave it 6, 7, 8. Doesn't really matter. And a 4 and 11. So the 6 maps to the 4. The 7 maps to the 11. And we ain't got no number that the 5 or the 8 maps to. It just sits there. So when it is there and it does not map anywhere, it's not a function, and well, it doesn't designate a function. I mean, meaning it's neither. It's neither a function or a non-function. So if they give you one like that, just put neither. It's neither a function or not a function. So shouldn't give you any problem there. And that's it for lesson number 84, and that was the second video B.